Hi, my name is Annette and this is Chemistry at Glance. Today we're going to practice some past paper questions on energy profile, distribution curves and catalysts. If you're not familiar with the topic, visit my post on my blog. I will leave all the links in the description box below. And we're going to start with the first question. In the reaction between magnesium and hydrochloric acid, explain why raising the temperature of the acid increases the rate of reaction. So you need to know that only molecules with enough energy will react. When we increase the temperature, the molecules move with more kinetic energy. This means they will all collide more often, and therefore there will be more successful collisions, because if they collide more often, there is a greater chance that they will be successful. And how I answer this is the energy is increased, so they move faster, therefore collide more often. This means more possible collisions that are successful. And let's go to the next question. State what is meant by a catalyst and explain how catalysts work. So the definition you need for catalysts is they increase the rate of the reaction by providing an alternative route without being used up. And this alternative route means a route with a lower activation energy. So less energy that the particles need to gain to collide successfully. This means they increase the rate of reaction. And here's the next question. It has lots of parts, so let's get started with it. The diagram below shows the distribution of molecular energies for a sample of but1ene. Draw a distribution curve for the same sample but at a higher temperature. So, if you read my post, you will understand or know a couple of tips that I got. So, the curve never touches the x-axis, as this one, and when the temperature increases, the peak moves to the right, but the area stays the same. I wrote it as a T2 because that means a higher temperature or the second temperature. And in this way, we actually have, just imagine we've got this line here going, saying the activation energy. When you increase the temperature, there is a bigger part of these molecules, because we've got all of this, that will reach the activation energy. Because in gases, there's actually a small percentage of all the molecules that will reach the activation energy. But when you increase the temperature, the percentage of these successful collisions will increase. I hope this makes sense. So part B. but1,3-diene dimerizes slowly when it is heated to over 200 degrees Celsius. Use these values, to calculate the initial rate of reaction. So, as you probably know, our rate is the change in concentration over time. So these are two concentrations, we just need the change in them. So 1 minus 2 minus 1.60 times 10 minus 2. This way we're going to find a change in them over the time, which is 200 seconds, I guess. So now we just put it all in the calculator, and this is what I got. And now we just press equals, and this gives us 3 times 10 to the minus 6. And our answer is this. That's the rate of this equation. of this reaction. Now, the next part says, state how the value for rate would change as the reaction proceeds at constant temperature. Give a reason for your answer. So, as you know, the rate would decrease. And this is because at the beginning, the concentration of the particles is greatest. And as the reaction proceeded, more of them already gained the activation energy, so they reacted. And a smaller part of these particles still have not reacted. So as you go along, the rate of the reaction slowly and slowly decreases. And I wrote concentration is greatest at the beginning and then decreases, and so the rate decreases. The dimerization of but-1,3-diene is an endothermic process, so it absorbs energy. Sketch an energy profile for this reaction, clearly showing the activation energy. So, energy profiles, we draw a graph, and you've got energy on this side and the extent of reaction on this side. It's an endothermic process absorbing energy, so we have less energy at the beginning and then it absorbs energy. So we got reactants and products. We also need to include the activation energy in this energy profile. And this is the activation energy. And that's all. If it was an exothermic reaction, this would look a little bit different, because in exothermic reactions, the energy is actually released. So we have more energy at the beginning, less energy at the end. And only this part is the activation energy. So in exothermic reactions, there's actually less energy needed for the activation than there is in the endothermic process. And now I've got our next question. The decomposition of gaseous hydrogen iodide, Hi, is represented by the equation below. Sketch and label on the axis below the energy profile for the above decomposition. And we know that it's exothermic because we have a minus right there. Minus means it's an exothermic, plus means it's an endothermic. And now we've got a minus, so it's an exothermic. And as I just showed you in exothermic reactions, the energy is released. So we have more energy at the beginning that we have at the end, because we release that energy, so it drops. So yeah, energy and extent of reaction. And now we draw our activation energy. The next part, instead of the reactants and products, we could also write 2Hi here. And in the products, we could do H2 gaseous plus I2 gaseous. Our next part says the energy profile for this. We have to draw, sketch and label on the axis below the energy profile for the same reaction if it was catalyzed. So if it's catalyzed, the activation energy decreases. So less energy, the Hi has to gain less energy for the particles to collide and react. A catalyst, that means with a catalyst. So as you can see, the activation energy was bigger here than it is now with a catalyst. This is our last question, it's a big one. at least the writing is a lot. The rate of the reaction between dolomite, mineral containing magnesium carbonate and calcium carbonate, and the hydrochloric acid increases by a large amount if the temperature is increased. Complete the following energy distribution curve diagram by drawing two lines that show the distribution of energies at two different temperatures. Label the line with at lower temperature T1 and the line at higher temperature T2. Use the diagram to help you explain why the rate increases as the temperature increases. So, we need a Boltzmann distribution curve right here. So our initial curve looks like this. T1. It's a low temperature. We've got activation energy right here. And the next curve, the peak is on the right, more on the right. The area is still the same. And of course, there is more molecules that have the required activation energy. So I basically just told you the answer to this question. Use the diagram to help you explain why the rate increases as the temperature increases. So this basically is that the fraction of molecules having the required activation energy, I forgot to write this, is bigger at a higher temperature, because we've got all of this compared to only this part for a lower temperature. And our last bit, one method for following the rate of reaction is by measuring the volume of CO2 produced. Evolved at suitable intervals. Briefly outline a different method. So it says that CO2 is released. So our another method could be placing the beaker or whatever it is that the reaction happens in on a balance and measure the loss in mass of CO2. We can do this with CO2 because CO2 is a heavy gas. So what you gotta do is place the reaction mixture on a balance and measure the gas loss, the loss of CO2. Of course, that has to be done at different time intervals. So you check the mass on balance every at a time. So every 10 seconds or 100 seconds, depending on how fast the reaction proceeded. This was all. Remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. As always, I'll leave all the links in the description box below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. Like, subscribe, and see you soon. Bye.